Hey students, before you get this video started, make sure your math notebook is open in front of you, that you are taking the notes on the right-hand side, and then when you get to those Edpuzzle questions, you can write your work on the left-hand side. Okay, so today the title of our notes is going to be 1.5. We're in section 1.5, which is all about greatest common factor. And oftentimes we refer to the greatest common factor as the GCF. GCF means greatest common factor. And today is September 14th, 2020. Our learning target for today is I can find the GCF of 2 or 3 numbers. So before we talk about what the GCF is, I just want to talk about what common factors are. What is a common factor? Common factors are factors shared by 2 or more numbers. So what I mean by that is that a common factor is a number that divides evenly into 2 or more numbers. For example, 4 is a common factor of 8 and 16. Because 4 divides evenly into both 8 and 16, it is a common factor of 8 and 16. Now that we know what the common factor is, let's talk about GCF, the greatest common factor. Well, it's exactly what it sounds like. It's just the greatest of all common factors. So sometimes numbers have more than one factor in common, and the greatest common factor is just the greatest of all of those common factors. The way that we are going to find the greatest common factor, the GCF, of numbers is by using prime factorizations. Remember that prime factorizations break our number up into all of its prime factors. So if we do that for 2 or 3 numbers, we can then identify what factors they have in common and what their greatest common factor is. So let's do an example. We are going to find the greatest common factor of 12 and 56. 12 and 56. So I said to do this, we were going to find the prime factorization of both numbers. That means we need to start with factor trees. So for 12, 3 times 4 makes 12. 3 is prime, so we end this branch. 2 times 2 makes 4. Both are prime, so we are done with our factor tree here. Now we can write out the prime factorization. So 12, our prime factorization is 2 times 2 times 3. Remember, we like to put it in order from least to greatest. Next, let's do that for 56. Well, we can get 56 by doing 7 times 8. 7 is prime, so we end that branch. We can get 8 by doing 2 times 4. 2 is prime, so we end that branch. And we can get 4 by doing 2 times 2. Again, 2 is prime, so we are done with our factor tree for 56. Now we can write its prime factorization. We have 2 times 2 times 2 times 7. All right, now that we have the prime factorizations written out, we are looking for things they have in common. We want to find things they have in common. Well, I see a 2 that is part of both of these. So that means so far we have a 2 in common. And it actually looks like there's another 2 they have in common. They each have a second 2 as well. So they have another 2 in common. There is nothing else they have in common. So right here, these are all of our common factors. They each had 2 2s. The way we get their greatest common factor is by multiplying those together to get 4. So again, all we did is we identified what factors they had in common. They each had 2 2s. So that is what we multiplied together to get our greatest common factor. So the GCF is 4. Okay, we're going to try that again. This time we are just going to find the GCF of 3 numbers actually instead of 2. So we're going to find the GCF of 45, 75, and 120. So I have to find the prime factorization of each of these. That means I need to make factor trees. We can get 45 by doing 3 times 15. 3 is prime. And we can get 15 by doing 3 times 5. Both are prime. So we are done with our factor tree there. We come over here and write out the prime factorization for 45. That's going to be 3 times 3 times 5. Now we repeat with 75. We can get 75 by doing 3 times 25. 3 is prime. And we can get 25 by doing 5 times 5. 5 is prime. So we are done with this factor tree. We can come over here and write out their prime factorizations. We have 3 times 5 times 5. And last but not least, 120. I know I can get 120 by doing 12 times 10. Neither are prime, so we have to keep going with both branches. We can get 12 by doing 2 times 6. 2 is prime, so we end that branch. We can get 6 by doing 2 times 3. Both are prime, so we're done on this side. Now coming over here to the 10, we can get 10 by doing 2 times 5. Both are prime, so our factor tree is complete. Now we can write the prime factorization. We get 2 times 2 times 2 times 3 times 5. So now that we have our prime factorizations, we are looking for common factors, numbers they have in common. Well, I see they each have a 3. So a 3 is one of our common factors. They also each have a 5. 3 and 5. And it looks like that's it. There's nothing else that they have in common. So again, we take our common factors, 3 and 5, multiply them together, and that is going to give us our greatest common factor, which is 15. So 15 is our GCF. Okay, let's just do one more example just to make sure we've got the hang of things. This one is going to be a word problem. So in this word problem, we are making gift bags for a party, and we have some supplies in front of us. In that pile of supplies, there are 18 chocolate bars and 24 lollipops. We are trying to figure out what is the greatest number of gift bags we can make that will all be identical and won't leave anything left over. So another way to phrase that question is I am asking, what is the greatest number of groups we can split this into? Or in other words, what is the greatest factor of both of these? What is the greatest common factor? So to find our GCF, we start by making our factor trees. 18 can be made by doing 3 times 6, and 3 is prime. 6 can be made by doing 2 times 3, and both are prime. Now we come over here and write out the prime factorization. We got 2 times 3 times 3. And then here for 24, we can get 24 by doing 2 times 12. 2 is prime. We can get 12 by doing 2 times 6. Again, 2 is prime. And we can get 6 by doing 2 times 3. Both are prime. So we can write out its prime factorization as well. We have 2 times 2 times 2 times 3. So now I start looking for common factors, things that they share. Well, they each have a single 2. That's one common factor. They also each have a 3. That's another common factor. There is nothing else they share. So now that I have all my common factors, I multiply them together to get the greatest common factor, and that is 6. So that means we can make 6 gift bags. We can make 6 gift bags that are all the same, that will not leave any materials left over.